record here. Thank you very much, Zoom. I'm going to right now turn it over to Carolyn Gay from the Caesar office to say a few words. Carolyn.
Hello, welcome to the 2021 CyberForce webinar series. I'm Carolyn Gay, DOE's Program Manager for CyberForce. I work in DOE's Office of Cybersecurity, Energy Security, and Emergency Response, or Caesar, and we work closely with our partner, Argonne National Lab, to put on the CyberForce competition and program. This year, we've expanded CyberForce to include 2 virtual Conquer the Hill competitions, a virtual career fair, and this webinar series, which we're holding tonight, in addition to our main competition event. We doing this because we want to inspire and help prepare students to pursue a career in the cybersecurity workforce. The main day-long CyberForce competition will be held virtually this year on November 13th, providing the opportunity for student teams to experience a realistic, energy-focused cybersecurity scenario. And as you're all aware, cybersecurity is a national priority and improving the cyber posture of our critical infrastructure is essential to our country's national security and economic well-being. As cyber threats increase, we encourage students to take advantage of CyberForce's opportunities to test and grow your technical and professional skills. Please visit the website for more information about the CyberForce program and to register your team for this year's competition. Thank you for joining us today, and please don't hesitate to ask questions. I'll now hand this over to John from PSM Partners.
Thanks, Caroline. Hello, everybody. So my name is John Porcaro. I'm an account manager at PSM Partners. I also have with me my team, Joe Kupiak and Jason Fritz. We're both solution architects. So just a quick little bit about us. We're a technology consultancy based in Chicago, and we focused on IT, outsourced IT services. So we kind of have 2 groups within this technology practice, which consists of roughly 50 engineers and architects. The first is our ongoing support model. It's just a managed services model, as we call it. And those services kind of include help desk, on-demand support, 24/7 monitoring, virtual CIO, et cetera. And then the second part of our business is the solution integration side, which is where both Jason and Joe sit. So services like infrastructure, project and program management, white glove deployment services, and then implementations and migrations like Azure migrations are all right in our wheelhouse. So we are very excited to just speak today and share with you our knowledge of the cloud. Our goal is really to have this webinar be collaborative. So please feel free to ask questions, raise your hand, and we'll try to get through all of those as best as we can. And with that said, I think I'll turn it over to both Jason and Joe.
Thanks, John. So hi, everybody. I'm Jason Fritz, and this is Joe Kupiak, my coworker. Also, just wanted to point out Andy Taylor is on the phone with us as well. We report to him. He is in charge of the solutions integration group that John alluded to. So, we're going to talk about cloud computing for beginners. This is going to be pretty high level, hopefully not confuse anybody. We just want to talk, kind of like in big terms and, higher level cloud computing, definitions and terminology and stuff. So to start, we thought we'd just do some opening questions. Now, I know everyone is muted. We have no video as well for all of the attendees, but if you can chat to us, some responses here, just kind of get it, get the juices flowing, get our brains working before we delve into some really boring stuff, basically. But, wanted to just get your ideas on a couple of different things, some answers to some basic questions about cloud computing. First one being, what are some of the most popular cloud computing services that you're aware of out there? Feel free to chat us some ideas.
We'll give everyone some time here to respond to these questions. If it warrants or if we deem it necessary, we can obviously elaborate or establish a dialogue here upon the responses.
Or if we get no responses, me and Joel just have to
We
ad
will-
hoc, you know.
We'll fill, yes, we'll fill the gap. Absolutely.
So any popular cloud computing service anyone's aware of? I'll throw it out there. Anyone here of AWS,
Yes,
Amazon Web Services?
absolutely.
How about Salesforce? Some people might not think of that as a cloud computing service, but it actually is. We'll get to that.
Google has their own GCP
Right.
as well.
Am I not, do I just not see chats or?
We've got the chats here. I'll go through their responses for you, Jason.
Okay, thanks.
You're welcome.
Next question then, if people can chime in some. What are some of the main advantages of cloud computing? I think everyone's probably more familiar with, you know, maybe on-premises data centers and stuff, which, as we'll see, is a kind of cloud computing in some way, shape, or form. But, you know, cloud computing kind of changes the game. It's not your on-premises data center anymore, right? So what are some of the main advantages of moving to cloud-based computing?
Interesting point that Amanda brought up, Jason, was cost savings.
Cost savings is huge.
Is the cloud always cheaper than an on-premise data center?
Yeah, it can be, and it may not be. Sometimes the cost is even equal. It all depends on the type of resources you're deploying in the cloud, what kind of, you know, services you're taking advantage of, even how you migrate your workloads to the cloud, you know, that might have previously been on premises, or how you build your workloads out in the cloud directly.
Absolutely. John mentioned security. Well, actually, my colleague Jason will be talking about that during one of the later slides in the presentation. Security is actually part of the shared responsibility model. As we'll see here, it can potentially be more secure than a regular, you know, on-premise environment, but that may not necessarily always be the case.
Correct.
Vasanth mentioned resource management and pay-as-you-go pricing models. I think
Yes.
those are both applicable to advantages.
Yeah, very good.
Yes.
Great. Well, thanks for you know, participating there. Kind of started off, hopefully, you know, like that it gets our brain going. So just to start, you know, we figured the best way, you know, to delve into what is cloud computing is to define it. Now, NIST, you know, which I'm assuming everyone has heard of, that's the National Institute of Standards and Technology. They define cloud computing as, and get ready, a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. So what the heck does that mean, right? Basically, what they're trying to say is it's just a hosted data center that provides you with your resources, whether they be compute, storage, you know, application layer. That's all that the cloud really is, I guess, at a base level. It's just another data center. You know, there's obviously things that run in the data center. There's different resources and products that are, you know, like considered cloud services, but really it's just another data center that houses all of, you know, the equipment for you, all of the baseline networking and hardware infrastructure, right? But because the way the cloud service providers, which we'll get to in a second, you know, host all of that that infrastructure for you, it makes it easier for you to also rapidly provision, you know, all of your workloads. There's, you know, a much lesser impact from a administration standpoint, management standpoint. You know, you get into things like infrastructure as code, which, you know, we won't touch on much here, but that obviously is a very automated way of deploying cloud resources. And DevOps as well. When you get into like DevOps functionality, that's a very fluid method of building applications and the data stores that the applications rely upon, and deploying those resources in a very easily repeatable process. So those are kind of some of the things that bolt on to what cloud computing provides us at a base level, which, like I said, is really just a data center with a bunch of racks and servers and stuff that they give to you. The business impact to, people that move to cloud computing, though, is a little different. Not only does it change the way the businesses access, consume, interact with their resources themselves, right? Their workloads, all the things that they move into the cloud or build in the cloud. Businesses also have to shift the way that they look at paying for those resources, paying for their IT infrastructure. This is basically a difference in, a capital expenditure model, which is, abbreviated by CapEx. I'm sure we've all heard CapEx versus OpEx before. So CapEx is a capital expenditure versus an OpEx or operational expenditure. Cloud computing really falls into the OpEx category because you're not paying for the traditional infrastructure as you used to. Say you had to build, example would be, say you had to build out, an entire new data center to house your on-premises infrastructure, and you would have to buy upfront the server racks, the servers themselves, the storage, the air conditioning, the power, the battery backup, the fire suppression system, all these things that create, or that you would need to make, your data center, be able to house the infrastructure needed to build your workloads in. You would have to make a hefty upfront investment, a large capital expenditure, would be necessary to build all of that out. For the cloud, you basically are paying for your resources as you consume them. So it's considered an operational expense rather than that capital expenditure, because you're not really necessarily paying for anything up front in that sense. The other good benefit, or the other benefit to operational expenditures, is it is somewhat easier to gauge your spending. It becomes a little bit more predictable. For example, say you have 5 virtual machines running in Azure and they're all a certain size and they all have a certain amount of storage associated with them. You can very easily determine exactly what those virtual machines are going to cost month to month, year after year, basically. And even if they grow in size, if they scale up or if they scale down, or if they, the amount of storage that they need changes in, the total amount, the utilization, or the type of storage, say they move from standard, like basic disk, to like premium SSD or something, you can easily gauge all of those differences in cost, basically. So the operational expenditures, is a shift in the way business deals with IT from how they always previously have. But it's a beneficial shift.
Absolutely. All right, I will continue elaborating on the points that my colleague Jason just made, specifically on the technical definition and the business impact of the cloud. First and foremost, there are 5 essential characteristics associated with the technical definition of cloud computing. You have on-demand self-service, resource pooling, rapid elasticity, measured service or services, and broad network access. There's 3 main benefits or characteristics also associated with the business impact of cloud computing. As my colleague Jason just mentioned, first and foremost is the fundamental shift between a CapEx to an OpEx expenditure model. Secondly, the improvement of service quality. And lastly, the access to new technology and services. So to pivot back and to go in more in-depth here, technical definitions. First and foremost, we have the on-demand self-service nature of the cloud. So you as a consumer, or me, myself, or Jason here, whenever we're deploying any assets within the cloud, we simply have the ability to provision resources without virtually any interaction from the cloud service provider. This could include compute resources, virtual machines, storage, hard disks for the virtual machines, or any related networking services that would facilitate the communication between virtual machines or some of the other services that exist in the cloud. Secondly, we have the resource pooling characteristic, and this is very unique to some of the larger cloud providers, so be it Amazon, Google, Microsoft. Through their investments of virtually billions and billions of dollars, they have the massive infrastructure and the knowledge and know-how to implement advanced virtualization and emulation techniques, and such that they can provide or aggregate this enormous pool of resources at any given point in time, provide this to any single individual consumer or group of consumers. Thirdly, we have the rapid elasticity characteristic of the cloud. And this works both horizontally by scaling out or in, and vertically scaling up and down. So vertically would be, as an example, associating additional CPU or RAM with the virtual machine. Horizontally is more looking at a load balance solution where you're adding additional virtual machines. This can be done either programmatically or manually via the console that the cloud providers provide to you. Fourth, we have the measured service. My colleague Jason actually alluded to this in one of the previous slides. The meter starts running as soon as you deploy resources in the cloud. And one of the main components of understanding your cost expenditure with the cloud is to look at the services over a period of time. And specifically for that period of time, how often they're online or deallocated. The cloud service provider is going to monitor the online or the uptime of all the resources that you have. It will aggregate this over some period of time, whether it's 30 days, a quarter, et cetera, and they will provide that cost to you via a chargeback model. Last, I have the broad network access characteristic of the cloud. Simply speaking, this provides you with the ability to access cloud resources virtually from anywhere in the world, as long as you have a device that is internet capable. Business impact of cloud computing, more specifically, the two main points to notice here, aside from the CapEx to OpEx shift, are secondly, improvement of service quality. So because of the vast, we're leveraging the economies of scale that cloud service providers implement within their architecture and infrastructure. Pretty much across the board, you're going to get a 99.9% minimum uptime of services, which by and large cannot be met by nearly any other institution or organization. Lastly, or thirdly, for the business impact, businesses get access to new technologies and services. This is absolutely amazing when it comes to business development and getting an edge in the market. Some specific services that businesses can leverage are big data analytics, artificial intelligence, machine learning algorithms. And most importantly, all these services are available at the click of a button.
I'd like to add too, most of those services are really not available on premises either.
No, not at all. And to even begin to host the infrastructure, for example, for big data analysis or artificial intelligence platforms, the cost would probably be prohibitive to even try to pursue any of those. Okay, next we have the cloud computing deployment models. So there are three main deployment models when we're looking at the cloud. We have a private deployment model, public, and lastly, a hybrid. The names, generally speaking, are reflective of their purpose. If you're looking at a private cloud, through and through, you can look at this just like you would as a normal data center. This would be some, a small private cloud could essentially be the server closet that you have in your office. The core component of the private cloud is that it's specifically offered to a selected group of users. This is not offered to the general public. You can access the private cloud over an internet connection or via an internal private network via switch, over your local LAN. Private clouds give businesses pretty much the exact same bang for your buck as the public clouds do, but the main core differentiator is that private clouds give you the additional control and adaptability due to having complete ownership of the underlying infrastructure. Some great examples of private clouds are Rackspace, or as I just mentioned, the rack of servers in your closet. For the public cloud, the main differentiator here is that it's characterized by providing computing services over the internet, strictly not looking to access these services over the LAN. In the vast majority of cases, the CSP is a third party. The top three biggest and most prevalent public CSPs are publicly traded companies, albeit Amazon with their AWS platform, Microsoft with their Azure platform, and lastly, Google with their GCP platform. For the public cloud, services are available to anyone on a pay-per-usage model, and they may be offered for free, but keep in mind that this is often for a limited time or with strict limitations. At the end of the day, the public cloud is still just another data center. It's just not owned by you. Lastly, we have the hybrid cloud model. And this is probably the most prevalent type of cloud, simply based on the requirements that businesses have for keeping data on premises and similar requirements. The hybrid cloud is a combination of the public cloud and a private cloud. Now, to make this really work for your business and to make it most efficient, it's highly recommended to have a dedicated high bandwidth, low latency connection between the private cloud and the public cloud. Reason being is that any latency that may be injected could severely affect the performance of the applications that are hosted in the two disparate systems. Hybrid clouds are most applicable to businesses or organizations that want to keep, for example, business critical applications or highly sensitive data on premises. And with those specific artifacts of the application hosted in one specific physical location, they can then leverage the public cloud to, for example, present the application layer or the presentation layer. And specifically with the private cloud, they can leverage the elasticity and scalability to ensure that the front end or the streaming component of that application is as fast as is possible for the consumers. To provide some substance and additional information here in regards to the cloud deployment models, we have a couple of use cases we'd like to go through with you. First and foremost, we have a small software company with limited capital. This is pretty much a shoe-in here to use a public cloud provider with a pay-as-you-go pricing model. The small software company does not have the capital or the money to take care of deploying a private cloud or to leverage a hybrid cloud, because that would also include the necessity of having a local large private cloud. Next, we have a law firm. In this instance, we give an example focusing on bankruptcy law, but this could be truly any law firm or any retailer or any institution that is experiencing basically dynamic growth. And with that, the public cloud may seem like the best fit or the quickest or the easiest deployment model, but there's a gotcha here. This law firm, and it could be a retail firm with some of their privileged information, but in this specific instance, this law firm has highly confidential data that they must keep on premise. So in this specific situation, the hybrid cloud is the best and truly only option for that scenario. Lastly, we've got a large corporation which recently made a substantial capital investment in upgrading its core data center. Again, alluding to what my colleague Jason mentioned earlier, this is a significant capital expenditure that this large corporation that it just made. And in this situation, it does not make sense to explore looking at any other third parties to host their infrastructure. Thus, a private cloud would make the most sense in this situation. Very good. And we have more cloud questions at this point in time. Very good. Okay, so I hope we might get a little bit better interaction here this time around, since everyone's got.
I found the chat thing too.
Okay,
so
good. All right, so we can look at it. All right, very good. So first and foremost, what is a multi-cloud strategy?
Good question. Anyone? More than one provider?
Absolutely, Amanda.
Gold star for Amanda.
Absolutely, two. Yes, two. We're keeping track here. So yes, generally speaking, multi-cloud strategy is leveraging greater than one cloud provider. In most situations, you're going to be looking at the public cloud providers, but there certainly are situations where you might be leveraging a mixture of hybrid clouds and public clouds to meet some sort of need or requirements.
Yep. Yeah, Vasant hit it on the head too. It's basically, it could be your own private cloud as well. Multi-cloud is just a combination of any clouds, I guess, right?
Yep, absolutely. Right. Next question, and we hope everyone gets this right, but we might be interested to find out what the answer is. Which CSP do you think has the largest market share and why?
Anyway. Google. Yeah, no, Mary got it.
And Amanda as well.
And Amanda. Well, yeah, she already got her gold star. So we'll give the gold star to Mary this time.
Mary, you get it this time around.
AWS, correct.
Yes, absolutely. So generally speaking, at the end of the day, AWS was the first to market in 2006. Next to market was pretty much Azure in around 2010 or so. So AWS had about nearly half a decade more time to allow their cloud to mature and offer new technologies and services available to their consumers. And because of that lead, AWS still is the market leader at this point. However, Microsoft is continually chipping away at that lead year after year. GCP is still stuck in third at this point in time, but only time will tell here in the next 5 to 10 years to truly see who makes it out at the end of the day.
Great. So we've gone through some basic terminology, what cloud computing means, definition, how it impacts businesses, and the deployment models. Now we're going to dive into the service models. The service models determine how the cloud computing resources are provided to you by the provider, basically, right? So hopefully this will make sense. We have a couple more slides that'll break this down in a little bit more, minute detail to hopefully drive the point home, the differences between these service models. So IaaS, the infrastructure as a service model, is probably the one everyone's most familiar with. It's essentially just like your on-premises data center, where you have, a virtualized infrastructure running, hypervisor of some sort, VMware, Hyper-V, what have you. Except in that model, your on-premise data center, you have to manage the hardware, the underlying network and server hardware, right? In the cloud computing service model, IaaS is all of that underlying network infrastructure and server infrastructure is managed by the cloud provider themselves. They basically hand off to you at the OS layer, the platform level. You have to manage the platform, the operating system itself, any middleware that might go along with those workloads, those virtual machines, and then the applications themselves, including any data, right, that might be, related to those applications. So, obviously, example is, a web server. You have a web server running in an IaaS environment in cloud, and it's running IIS, and you also have a SQL server virtual machine that houses the database that provides the data to that application front end. You have to manage the Windows operating system on both, as well as the application itself and the SQL data that runs within it, right? The PaaS service model, which stands for Platform as a Service, takes it up one more notch from a cloud service provider perspective. They provide the underlying network and server infrastructure, just like in the IaaS world. But in the PaaS service model, they also provide the operating system and any middleware that might exist as well. So a good example of a PaaS service in the cloud, oops, sorry about that. A good example of a PaaS service in the cloud would be a Microsoft SQL database instance. So in my previous IaaS example, you had a Microsoft SQL server that you managed. You had to manage the operating system and the SQL server platform itself. In this case, you don't have to manage the operating system or the SQL server platform. They just basically give you a database instance that you can connect to with all the normal tools that you would connect to a SQL database with. You just don't have to manage any of that underlying middleware, operating system, or platform. The service provider provides all of that to you. All you need to manage is the application layer. And then obviously the data in this example within the SQL server itself. The SaaS model, software as a service model, is the cloud service provider basically manages everything, right? They are basically handing you a packaged application and everything behind it. They manage, they take care of. There's nothing that you need to do outside of maybe some customizations or other things that they allow you to do to the application front end that you communicate with or consume. An example I think like we talked about would be like Salesforce or Dropbox, right? Like those are SaaS solutions You just basically install the Salesforce app or install Dropbox, and they manage everything else from there. You just get the functionality of whatever that application is they provide. So a way of kind of breaking this down, which the different service models lead into this shared responsibility model that Joe alluded to earlier. A good, easy way of kind of explaining the shared responsibility model, I feel, is this pizza as a service, right? It just kind of makes it simple for everyone to understand, especially me. So if you think of it in terms of, pizza, if you wanted to create, your own pizza, I almost said build again. If you wanted to build your own pizza, and cook it and make it at home, you basically have to do all of these. You have to provide all of these things, right? The table you're going to eat at, any kind of a drink that you want to have with it, all of the pieces of the thing you're going to use to cook the pizza dough, sauce, topping, cheese, everything you need. The whole kit and caboodle, right? Like that's what you need to do in a traditional on-premises service model, basically, if you wanted to build your own pizza, right? If we relate that to, if we move it up a notch and we say, well, I want an infrastructure as a service pizza, I still have to provide, the table I'm going to eat on, the drink I'm going to have with it, and the means of cooking that pizza. But the provider is actually going to give me the pizza itself. Think of this as the tombstone model, I guess you could say, right? Like you go to the grocery store, and buy your tombstone and bring it home and pop it in the oven, eat it at your table, right? If we change to the platform, if we look at the platform as a service pizza model, that's basically now you're just supplying the table and the drink, right? Like you're getting that pizza delivered from your own, personal favorite mom and pop shop, which if you live in Villa Park would be Dominic's. There's no other correct answer, just so you know. Anyways, you only are provide, you only have to provide the table and the drink, to eat that pizza with. That's basically cooked and built for you and delivered to your front door, right? So that's the PaaS pizza model. And then the software as a service or SaaS pizza model is you're going out to eat, right? You're going to a restaurant, you're going to go and sit there and they're going to build the pizza, they're going to cook the pizza, they're going to deliver it to your table and provide you with the drinks. Hopefully that makes sense. This is the shared responsibility model in actual IT terms. So let's translate all of that pizza as a service into cloud computing terms and general IT terms. So on premises, once again, from applications all the way down to networking, right? Like you manage the whole stack, right? Like, even, what, I guess the other like residual things even, right, that aren't even called out here. Like, we talked about earlier, like the power, AC, fire suppression systems, all of that stuff is stuff that you have to implement and manage and maintain, right, in a non-premises, in a non-premises service model, I guess. Infrastructure as a service, once again, from the networking layer all the way up to the OS layer, that's managed by the provider, right? And what they mean by OS here is the hypervisor, I guess you could say. That's really where it comes, that's where they hand it off. Because in an infrastructure as a service model, you do get a virtual machine. You're building a, you have to manage the operating system that it runs on. Basically, this diagram is just considering that the middleware, right? But from middleware on up to the application itself, you have to manage an infrastructure as a service model. The PaaS service model, vendor managed services, goes all the way up to the runtime, right? So they're handling, once again, I guess in my SQL, example, like they're basically handling the SQL service, the SQL Server service itself, right? Like they're basically managing the SQL Server instance itself, and they're just handing you a database that runs within that SQL service, right? So they manage, closer to 75% of the infrastructure that your applications and or data run upon. And then in the SaaS model, obviously everything, as we talked about, is run, or is managed by the vendor themselves. So I think that pretty much sums up are part of this. What we wanted to do at the end of this here is, kind of opened it up to questions and or open discussion. If anyone has, like I said in the beginning, this was really high level. Obviously, hopefully this all made sense. It was quick and to the point too. It was short, 30, 40-minute presentation, but we do want to open this up to any questions or just open discussion anyone has. I lost my chat window.
And, keep in mind, this could be questions that are more broad in nature as well. You could certainly ask, how do I get started in cloud computing, or what might be a foray or an entryway into a cloud engineering role or cloud architecture, or, I'm unsure, I'm in college, I don't know what to study, what avenues or what might be the best opportunities for good job security in the future. Things like that are also acceptable.
Anything's fair game. We're obviously not, total experts, but we kind of know what we're talking about here to some degree. One thing we didn't cover in this slide deck, but something that might be open for discussion is, cloud migration methodologies. That's with the adoption of cloud for most organizations, it's like, great, like we want to move to the cloud, but how do we do that? That's something that comes up a lot. It's really a whole other topic, just like cloud security is a whole other topic, a whole other ball of wax unto itself. But we're, like I said, we're happy to entertain and answer any questions that we can from any of you. Or we could just tell some jokes for the next 5 minutes.
Absolutely.
I'm not a comedian though, so. Proprietary versus open OS. Vasanth, can you expound a little bit more on that, if you don't mind?
Yeah, I guess we talked about the private cloud and some data issues, so that's probably more proprietary in my sense. And of course, we do not want to monitor or adapt to the current operating systems, which is like Windows, Mac, and of course Linux is the open source. So the open source is probably a good answer in the small space of the OS store. So, but again, the cloud is highly proprietary. When the data goes into Google Cloud, probably they can monitor us, or we don't know how they're using the data.
Gotcha. Yeah, I think I see what you. So with migrating to the cloud or building workloads in the cloud, there is a much more prevalence of open source operating systems, obviously, out there. In fact, it's no question for AWS. I want to say AWS runs like 80 to 90% Linux, if not more. Azure actually runs more Linux machines now than Microsoft operating systems within all their workloads as well. So open source operating systems and platforms are definitely way more prevalent, and probably more of the resource types that you would yeah, exactly. And yeah, Linux is fast growing workload. Basically open source is, especially with Microsoft embracing open source as they have over the few years, there's jokes that Windows 11 is actually built on a Linux kernel. I don't know if you guys have heard that. Maybe not, I don't know. But yeah, I think there's more open source operating system and platform adoption with the cloud as well that organizations have to be ready for.
Yeah, and I think a very important aspect of that, specifically in regards to the operating system. If you're looking at an operating system, you're looking at running a virtual machine. And anytime that you're running a proprietary or closed source operating system, there's most likely a charge or a fee associated with that. So any Windows-based virtual machine, whether you deploy it in AWS, you're going to be charged a fee by the cloud provider for that licensing model, specifically for the operating system. If you have hundreds or thousands or possibly tens of thousands of virtual machines, if those are running 24/7 by 365, those charges for the operating system start to add up, and they add up very quickly sometimes as well. Well, when cost comes into play, you might have businesses reconsidering whether they want to use a proprietary versus an open source operating system.
Correct. Great question, Vasan. Thank you. Anyone else? Questions? Okay. Well, I think we'll close it up here then. Thank you, everybody, for joining. Hopefully this was informative. Appreciate everyone's attention and go consume some cloud.
Yeah, thank you for joining. Absolutely. We'll hand it back over to you, Amanda.
Perfect. Thank you guys a ton for that. I learned a lot. I know I answered questions too, but I made a good guess more than anything, especially on the AWS one. I had to think there for a moment. So quick notes for those that are on. Again, thank you for joining. Next month, our next webinar is October 13th. Not an unlucky day. It's not a Friday. It's a Wednesday, but it is, I guess, the month of October. So who's to know? We'll be talking about our newly released workforce development portal that we've entitled Castle. So if you're interested in seeing what that looks like and getting a quick tour of that before it fully goes live, join us on that webinar. That can be seen at the cyberforcecompetition.com/webinar series if you want to sign up for that. Otherwise, just a quick reminder that the CyberForce competition application is open. That's open until October 1st. So please be sure to get your teams registered before then, and or volunteer registration is open as well until October 1st. If you have any questions, feel free to email us. Otherwise, have a great night, everyone. Thank you.
Thanks, everybody.